Hey everyone, welcome back to the channel. Have you ever wished you could go back in time, maybe to fix a mistake, relive a happy memory, or even just to see what dinosaurs were really like? Or perhaps you're more interested in the future, wanting a sneak peek at flying cars and what humanity will become. The idea of time travel has fascinated us for centuries, filling our books, movies, and dreams. But is it just science fiction, or could it one day become science fact? Let's dive into the mind-bending physics of time travel. First, we need to understand what time actually is. Most of us experience time as a constant, forward-moving arrow. 1 second follows another, and we can't seem to go back. But one of the most brilliant minds in history, Albert Einstein, completely changed our understanding of time. Through his theories of relativity, Einstein showed us that time isn't absolute. It's relative. It can stretch and shrink depending on how fast you're moving and the strength of gravity around you. This is a concept called time dilation. So, how does this help us travel through time? Well, let's start with traveling to the future. Believe it or not, traveling to the future is not only theoretically possible, it's something that happens all the time, just on a very, very small scale. According to Einstein's special theory of relativity, the faster you move through space, the slower you move through time, relative to a stationary observer. Imagine you and a friend synchronize your watches perfectly. Your friend stays on Earth, while you hop on a super advanced spaceship that can travel at, say, 99% of the speed of light. You fly around for what feels like a year to you, and then you come back to Earth. When you land and meet your friend, you'll find that your watch says 1 year has passed, but your friend's watch might show that 10 or even 100 years have gone by on Earth. Congratulations, you've just fast-forwarded into Earth's future. This isn't just a theory. It's been proven. Astronauts on the International Space Station are moving much faster than we are down on Earth. As a result, they age slightly slower. When they return, they are a few milliseconds younger than they would have been if they'd stayed put. It's a tiny amount, but it proves the principle is real. To make a significant jump into the future, we'd need a spaceship that can travel close to the speed of light, something our current technology is nowhere near achieving, but physics allows for it. So, future travel. Check, it's on the table. But what about the one everyone really wants to know about? Traveling to the past? This is where things get much, much trickier and way more speculative. The laws of physics as we understand them don't seem to forbid it outright, but they present some massive hurdles and mind-boggling One of the most famous theoretical pathways to the past is through something called a wormhole, also known as an Einstein-Rosen bridge. Picture space-time as a giant sheet of paper. To get from one point to another, you'd normally travel across the surface. A wormhole is like folding that paper in half and punching a hole through it, creating a shortcut between two distant points in space and, potentially, time. If you could stabilize a wormhole, one end could be kept stationary while the other is taken on a high-speed journey. Due to time dilation, the moving end would age slower. So, you could enter the younger end of the wormhole and exit from the older end back in the past. It sounds cool, right? But there's a catch. A huge one. First, we've never actually observed a wormhole. They are purely theoretical. Second, even if they exist, calculations suggest they would be incredibly unstable, collapsing the instant anything tried to pass through. To keep one open, you'd need a type of exotic matter with negative energy or negative mass. We don't know if such matter exists, or if we could ever create it. So, wormhole travel is a big, big maybe. Another idea involves using the intense gravity of massive spinning objects. Some physicists have proposed that a spinning black hole, or a huge, infinitely long spinning cylinder, could warp space-time so much that it creates what are called closed time-like curves. These are essentially loops in time that would allow you to travel into your own past. Again, this is highly speculative. We're talking about manipulating objects with near-infinite density and mass, something far beyond any conceivable technology. But let's say for a moment that we solve all these technological problems. We build a time machine. We can go back. This is where the paradoxes come in, and they are real head-scratchers. The most famous one is the grandfather paradox. What if you go back in time and prevent your grandparents from meeting? If they never meet, your parent is never born, which means you are never born. But if you were never born, you couldn't have gone back in time to stop them in the first place. Tease. A logical contradiction that seems to make travel to the past impossible. How do physicists try to solve this? There are a few interesting ideas. One is the Navikov's self-consistency principle. It basically says that the laws of physics will conspire to prevent any paradoxes from happening. So, you can travel to the past, but you can't change it. If you tried to stop your grandparents from meeting, something would always happen to prevent you from succeeding. You'd slip on a banana peel, your time machine would break down, a bird would distract you at the crucial moment. The universe would enforce a kind of plot armor for history. The past is fixed, and anything you do was already part of the history that led to you going back in the first place. Another, even more wild idea comes from the world of quantum mechanics. The many worlds interpretation. These theory suggests that every time a quantum measurement is made, the universe splits into multiple parallel universes, one for each possible outcome. In this framework, if you go back in time and change the past, you don't actually change your own history. Instead, you create a new timeline, a new branch of reality. So, in the universe you travel to, your grandparents don't meet, and a version of you is never born there. But you still exist, because you came from the original timeline where they did meet. Scoo. You'd essentially be a refugee from another reality, unable to return to the exact universe you left. This neatly avoids the paradox, but it opens up a whole new can of worms about an infinite number of parallel universes. So, where does that leave us? Is time travel possible? Traveling to the future is almost certainly possible, given enough technological advancement to reach near light speeds. It's an engineering problem, not a physics one, but traveling to the past. It remains firmly in the realm of theoretical physics and science fiction. While some theories suggest it might not be impossible, the obstacles are monumental. We'd need to find and control exotic matter, manipulate the gravity of black holes, or confirm the existence of parallel universes. Perhaps the biggest takeaway is how strange and wonderful the universe really is. Our everyday experience of time as a simple one-way street is just an illusion. Reality, as described by physics, is far more complex and bizarre. Whether we will ever be masters of time, able to journey to yesterday or tomorrow, remains one of the greatest unanswered questions. But the quest to understand it pushes the boundaries of our knowledge and imagination. And who knows what we'll discover along the way. Thanks for joining me on this journey through space and time. What do you think? If you could travel in time, where would you go and what would you do? Let me know in the comments below. Don't forget to like this video and subscribe for more deep dives into the biggest questions in science. See you in the next one.